We did a question like this in class today. And let's just find the equation of the tangent line to y equals tangent cubed x at pi over 4 comma 2. In order to do that, we need to find the derivative, because remember the derivative is just the slope of the tangent line at whatever point. Recognize we got a trig function to the third power, so that should indicate that we have to use the chain rule. I suggest, this is the way I always do it, is the way I like to see it, to rewrite that tangent of x to the third power. Okay, those two things mean the same thing. Now I can recognize that the chain rule does exist a little bit more, a little bit easier than what I could see it existing here. We use basically the power rule of the chain rule to start this. So I'm going to bring that 3 out in front. So the derivative then, y prime, is going to start as 3. Now I'm going to take the tangent of x. Okay, and now because that 3 came out, the power rule says you need to subtract a 1 from that, and you get the power 2. Okay. So essentially this is a tangent squared of x. Okay. Remember, we said this in class, when I take the derivative of the outside part, okay, and that was with the power of 3. Okay. And now I want to go and use the chain rule to work inside and then further inside, however big my function is. Okay, I might have to work inside 3 or 4 different times. Here we only have to work at, we start on the outside and we work inside to the tangent function, and then we would work inside to the actual function of x here, but we're not really, the derivative of that would be 1. But when we work back inside, we always want to go back to the original function and work inside of that original function. Don't work inside of this one. Okay, it's not going to provide a problem in this question, but in some questions, if I just look, now I took the derivative of the inside of this, well, that's going to be a problem sometimes. So I'm going to go back here and say, now what was the derivative of the inside? Well, that's tangent. So what's the derivative of tangent? And that's secant squared of x. Okay, and then the chain rule actually tells you to go into that part and take the derivative of that. Well, the derivative of x is just 1. Okay, if that was a 2x, then we would take the derivative of that and say then it's 2. Hopefully that's something that we understand right now. We're going to evaluate this thing at pi over 4 comma 2 because that's where we're interested in our tangent line. So what we're going to do, I'm going to rewrite this derivative as y prime is equal to 3. I'm going to leave this as tangent of x squared. And I'm going to rewrite that as secant of x squared. Okay. Now the reason I do that is because I want to make sure that I evaluate tangent at pi over 4 and then square it, and then evaluate secant at pi over 4 and then square it. If I leave it looking like something like this, a lot of people will forget that they have to square that value. This form here, and it's kind of hard to forget that. So what we're going to do is, I'm just going to substitute pi over 4 in for my x. So I get tangent of pi over 4 squared times secant of pi over 4, that quantity squared. Okay. Tangent pi over 4, if you think about your unit circle, pi over 4 is right here, and that's a cosine value of radical 2 over 2 and a sine value of radical 2 over 2. Okay. So the tangent is sine over cosine, so it's radical 2 over 2 divided by radical 2 over 2, which is just 1. So really we get 3, and now this stuff in the brackets, tangent of pi over 4, that becomes a 1, and then we'll square that. It really doesn't have any effect then. And now the secant of pi over 4, well, secant, kind of do some scratch work down here, secant is equal to the reciprocal of cosine, so 1 over cosine. Okay, so now what I would actually do is, if I wanted the secant of pi over 4, I would write that as 1 over cosine of pi over 4. Okay? And then the reciprocal then, secant of pi over 4 is 1 over cosine of pi over 4. So I need to evaluate then cosine of pi over 4. Well, cosine is that value right there. It's radical 2 over 2. The reciprocal of that then is going to be 2 over radical 2. So the secant of pi over 4 is 2 over radical 2. Okay? And then obviously I want to square that. So now what I end up with is 3 times 1, which is 3. And then this stuff here, 2 squared is 4, radical 2 squared is 2. So I end up with 2 there. So we got 3 times 1 times 2 is 6. So y prime is 6. And remember, y prime, the derivative, is simply just the slope at the tangent line. So I'm going to erase this stuff. Okay, we went through all that derivative just to find that slope value of 6 at x being pi over 4. We want to find the equation of the tangent line. So I'm going to go y minus y1 is equal to m times x minus x1. Now what's nice is this value up here, that's your x1, that's your y1, we just found our slope of m. So now we just go ahead and substitute those values in. So you get y minus 2 is equal to 6 times x minus pi over 4. And now I'm going to have y is equal to 6x. That's going to give me 6 divided by 4 is 3 halves, so minus 3 halves pi. And then I'd add the 2 to both sides. And I get plus 2. So now that thing there is the equation of the tangent line to the graph of y equals tangent cubed x at pi over 4 comma 2.